A network of three resistors of resistances R1, R2, and R3 is shown in this figure. We see that they are connected in series with each other. The individual potential differences across the resistors are V1, V2, and V3. The current in the combination of the resistors is I, and the total potential difference across the combination is V. Show that the combined resistance of the network is given by this equation. So we have to prove that for a series circuit, resistors or resistances are added as a direct sum. So we know for this series circuit, the sum of all these voltages should be equal to the total voltage to conserve energy, right? This is just coming from the conservation law of energy. So V is equal to V1 plus V2 plus V3. So that's how the energy is conserved. Now, from this, we know that V is equal to I times R, right? So if I substitute this in this expression, Ohm's law here, so I have IR, which is R is the total resistance, times I V1, because the current is the same, plus I V2 plus I V3. But V1, I said V, I meant R, right? R1, R2, and R3. Clearly, you see that the I cancels from all sides, and you get R is equal to R1 plus R2 plus R3. So you have to remember this from conservation of energy. Sometimes it's also referred to as one of the Kirchhoff's laws, but Kirchhoff's laws is just the restatement of conservation of energy in terms of circuits, right? So essentially it is just the conservation of energy. All right, next we have a battery of electromotive force of 8 volts and negligible internal resistance is connected to a thermistor. A switch X and two fixed resistors are shown over here. So this is the diagram. We have battery, we have resistors, and this is a thermistor which is connected with a switch. Resistor 1 has a resistance of 6 kilo ohms and R2 has a resistance of 4 kilo ohms. We are said that the switch X is opened. Calculate the potential difference across R1. So when this switch X is opened, what would be the potential across R1? So this is the total potential, and this is R1. We know that we can write an equation for this for value of V across R1, right? And so that equation would be V over the total EMF of the battery is equal to the resistance R1 divided by R1 plus R2, right? So this is basically a ratio where this corresponds to R1 and EMF corresponds to the total resistance. It's a series circuit, so it's R1 plus R2, right? And again, this is coming from the conservation of energy. V is equal to IR, which says that total voltages are the sum of individual voltages, which is why we can do this. So this would become V over 8.0 is equal to R1, which is it was 6.0 kilo ohms, so 10 raised to power 3 divided by the sum of the resistance is 4.0 plus 6.0 into 10 raised to power 3. If you rearrange this for V, you get 4.8 volts. Now they're saying that switch X is closed. The resistance of the thermistor is now given as well. Calculate the current in the battery. Now if you look at this thing, if the X is closed, then these two are both R2 and the thermistor are parallel in each other, right? So we need to figure out first what would be the total parallel resistance. So we know this is 1 by 4 plus, so 1 by 4 kilo ohms plus 1 by the value on the thermistor is given as 12 kilo ohms, so plus 1 by 12 kilo ohms, and then you inverse this. So this gives you the parallel resistance of the two resistors as 3.0 kilo ohms. So that's the total parallel resistance. Now we can easily find the current, right? So the parallel resistance is 3.0 kilo ohms. So for current, which is I, we'll have V, the total voltage V over, because now the circuit is in parallel, so the voltages are same across both the resistors as the total EMF of the battery. So I'll just write it as 8.0 volts divided by the sum of the resistors 3.0 kilo ohms plus the other one, which is 6.0 into kilo ohms. And then you can just write this for kilo, write 10 raised to power 3, and then you do the math, and this gives you 8.9 into 10 raised to power minus 4 amperes. So that's the total current through the circuit. Now they're saying that the switch X in the circuit in B remains closed, the temperature of the thermistor decreases. Temperature is decreasing by reference to the current in the battery state, and explain the effect, if any, of the decrease in temperature on the power produced by the battery. Now we know what happens. The thermistor is going to increase the resistance, right? Why? Because they're saying that the temperature of the thermistor is decreasing. So we know a relationship between resistance and temperature. If we have a higher resistance, or when we have a lower temperature, that's when we have a higher resistance, right? Because and in this case, the temperature of the thermistor is decreasing, so the resistance will increase, right? So the resistance increases due to the temperature change, which would mean, if the resistance increases, that would mean that the current in the circuit has to decrease, right? Because that's resistance is increasing, it's causing constriction to the flow of electrons, so the current decreases. And we know if current decreases, then P is equal to V times I, implies that if the current is decreasing, power also decreases.